So let's continue, my dear friends. So if you see in the last session, we have completed sets and relations, right? Now, in this session, what we'll do, our target will be to complete functions and we'll start with probability as well. Okay. Now, coming to functions, what is basically a function? See, function is nothing but a rectified form of a relation is called as function. Now, before understanding functions, you need to understand range, domain, and codomain. Like, say, for example, my dear friends, I'm having set A 1, 2, 3, 4, 5. I'm having set B A, B, C, D. Two sets I'm having. Now I have developed a relationship A cross B. And from that relationship A cross B, I have taken one subset. Okay. That subset, a relation from A cross B subset is somewhat like this. It is 1 comma A, 2 comma B, 3 comma C, 4 comma C, and 5 comma C. Now, what is domain? The entire set A is called as domain. The entire set B is called as codomain. What I'm telling? The entire set A is called as domain. The entire set B is called as codomain. Now, 1, 2, 3, 4, 5, A, B, C, D. Now, if you see 1 is mapping to A, 2 is mapping to B. See here it is given as mapping. Here it is given as mapping. 1 is mapping to A, 2 is mapping to B, 3 is mapping to C, 4 is mapping to C, 5 is mapping to D. 1 to A, 2 to B, 3 to C, 4 to C, and 5 to C. Okay. Where the mapping is happening, that is called as range. Try to understand once again, the entire set A is called as domain. The entire set B is called as codomain. Where the mapping is happening, that is called as range. So before starting functions, you need to understand three things. What is domain, what is range, what is codomain. Okay, we haven't started functions yet. Okay, so before starting these functions, we need to understand these three things: domain, range, and codomain. Domain means where the mapping starts. Where the mapping starts, that is domain. Where the mapping is ending, that is called as range. The entire set number B is called as codomain. Okay, so I hope the words domain, codomain, and range is clear. Always remember the range will be subset or equal to codomain. The range cannot be greater than codomain. The range will be subset or equal to codomain. Now, what is a function, sir? Functions are nothing but relations itself, my dear friends. But a relation is a function when two conditions are satisfied. Every element in domain has a mapping and it has only one mapping. Now see here what is telling. All functions are relations, but all relations are not functions. Range is subset to codomain. Let me explain this. So try to understand the linkage between all these things. First, we understood something called as sets, right? Using these sets, we have developed something called as Cartesian product, written as A cross B. Next, the subset of Cartesian product, the subset of Cartesian product A cross B is called as a relation, right? A good relation is called as function, or a good relationship transforms to a function. Now, how a relationship is transformed to function. If you want a relation to be transformed to function, there are two conditions. Condition 1, condition 2. Now, what is condition 1, condition 2? Condition 1 says every element in domain has a mapping. And it has only one mapping. It has only one mapping. Let us understand this, my dear friends. Like say, for example, I'm having set A is equals to 1, 2, 3, 4, 5. Set B is equals to A, B, C, D, E. Okay. Now I'll give you three cases. Case one, case two, case three. We need to decide whether this relation is a function or not. R1, 1 comma A, 2 comma B, 3 comma C, 4 comma D, 5 comma E. Next case 2, 1 comma A, 2 comma A, 3 comma B, 4 comma C, 5 comma D. Case 3, 1 comma A, 1 comma B, 2 comma C, 3 comma B, 4 comma, let's take 3 comma D, 4 comma E, and 5 comma E. Okay, these are the three relations what he gave. Relation 1, relation 2, and relation 3. These three relations, I need to tell which relation is a function here. Now see here, well, how will I solve this? First, let me draw the domain and codomain. 1, 2, 3, 4, 5. A, B, C, D, E. Okay. Copy. Paste. Paste. This is case 1. This is case 2. This is case 3. Okay, now see here. Let's make the mapping here. I'm having 1 comma A. 1 is mapping to A, 2 is mapping to B, 3 is mapping to C, 4 is mapping to D, 5 is mapping to E. Is it a relation or not? First, it's a relation. That's the pakka. Because set A, how will we say a relation? A relation is ordered pair X. It's a subset of an ordered pair X comma Y, where X belongs to set A and Y belongs to set B. So obviously it's a relation. Now let's check if it's a function or not. First, every element in domain has a mapping. Is every element in domain having a mapping? Yes, every element in domain is having a mapping. Next, it should have only one mapping. Is it having only one mapping? Yes, sir, it is having only one mapping. Next. So, is the relation? Yes. Is the function? Yes. Let's go for the second example. 1 is mapping to A, 2 is mapping to A, 3 is mapping to B, 4 is mapping to C, 5 is mapping to D. First, is the relation? Yes. Is the function or not? Let us see. First, every element in domain has a mapping. Every element in domain is having a mapping. Next, it should have only one mapping. Yes, it is having only one mapping. Means only one arrow should pass from domain. Is only one arrow passing from domain? Yes, only one arrow is passing from domain. From number 1, only one arrow is passing. From number 2, only one arrow. From number 3, only one arrow. From number 4, only one arrow. From number 5, only one arrow is passing. Next, case 3. Is the function? Yes. 1 is mapping to A, 1 is mapping to B, 2 is mapping to C, 3 is mapping to D, 4 is mapping to E, 5 is mapping to E. First, every element in domain has a mapping. Yes, every element in domain has a mapping. It has only one mapping. But here, one is having two mappings. One is mapping with A, one is mapping with B. So, yes, it is a relation, but unfortunately, it is not a function. Okay, simple, my dear friends. Understand, every element should have a mapping and only one arrow must pass. Only one arrow must pass. Okay. Next, case 4. Tell me whether it is a function or not. Yes, it is a relation. Tell me whether it is a function or not. Yes, no. Yes, sir, it is a function. It is a function. Every element in domain is having a mapping? Yes. Every element in domain should have only one mapping, means only one arrow should pass. Okay. Next example. One is mapping to A, 2 is mapping to A, 3 is mapping to 1 is mapping to A, 2 is mapping to B, 3 is mapping to C, 4 is mapping to C. This is case 5. Is there a relation? Yes, it is a relation. Is it a function? What do you think? Is it a function? No, sir, it's not a function. Why? Here 5 is alone, so it's not a function. Okay. Next, case 6. One is mapping to A, 2 is mapping to A, 3 is mapping to B, 4 is mapping to B, 5 is mapping to C. Is the relation? Yes. Is the function? Yes, sir, it is a function. See, from every element, arrow should pass. From every element, only one arrow should pass. Just see like this. Is only one arrow passing from every element? Yes, only one arrow is passing from every element. So it's a function? Yes, it is a function. If you're getting confused, you can see like this. Now see here. Is only one arrow passing from every element? Yes, only one arrow is passing from every element. Is the function? Yes, it's a function. Now see here. Is only one arrow passing from every element? No. From 1, 2 arrows are passing. So it's a function? No, it's not a function. So I hope the concept is clear, my dear friends. What is the function? A relation is function if every element in domain has only one as a mapping and has only one mapping. All functions are relations, but all relations are not functions. Always remember, range is always subset or equal to codomain. Now, what are the types of functions what we have? Basically, 4 types of functions we have. One function, onto function, bijective function, and into function. See, very rarely he is asking questions on these concepts. Okay, but let's touch them once. I guess 6 years back, questions were asked. From past 6 years, no question was asked on functions. Okay, but yeah, on this questions are asked in the exam. But let's once go through types of functions so that our concept will be clear. Now, types of function. One function. One element maps with only one element. Now see here, one function. What are not functions? Let me cancel them first. This is not a function. This is not a function. First, one element maps with one element, that is called as one function. Is it one function? Yes. 1 to 1. One element is mapping to one element. Is it one function? No, sir, it is not a one function. Why it is not a one function? One element should map only with one element. Is the function? Yes, it is a function, but it is not a one function. Is it a one function? No, sir, it is not a one function. Is it a one function? No, sir, it's not a one function. Only this is one function. Balance all are not one functions. Okay, only one element should map with one element 1 to 1. Then it is one function. Next, onto function. Range and codomain must be same. If range and codomain is same, then we call it as onto function. Now, onto. Do you think it's an onto function? What is range here? A, B, C, D, E. What is codomain here? A, B, C, D, E. So it's an onto function. Is it an onto function? What is range here? A, B, C, D. What is codomain here? A, B, C, D, E. So it's not an onto function. Is it an onto function? What is range here? D is range. Or what is codomain? A, B, C, D, E. So it's not an onto function. Do you think it's an onto function? No, sir, it's not an onto function. Why? Range and codomain must be same. If range and codomain both are same, then only you call it as onto function. Your range is ABC. Codomain is ABCDE. It's not an onto function. Next, bijective function. If it is both 1, 1 plus onto, if it is 1, 1 plus onto, you call it as bijective function. So I hope only this is bijective. Is bijective. Okay. Next, into function. If range is less than codomain, we call it as into function. Onto and into are complementary. If it is onto, it won't be into. If it is into, it won't be onto. Okay. Can be only one. It cannot be both range and into. Sorry, onto and into. It can't be both. Okay. Range is less than codomain. Yes. So it's an into function. Range is less than codomain. Yes. It's an into function. Range is less than codomain. Range is less than codomain. Yes. So it's an into function. Take 2 minutes time and just look into all these 6 cases. See if any doubt is there in types of functions. Okay, if there is no doubt, let's see few examples. Yes, sir, let's see few examples. First, x comma y such that x is equals to 4. What type of function is this? With 1, 1, onto, into, bijective, or it's not a function only. X comma y such that x is equals to 4 and y belongs to real numbers. So what happens here? I'm having x, I'm having y. X is given as 4. Okay. Y is given as real numbers. Any real numbers you take. -2, -1, 0, 1, 2, 3. He's telling x is equals to 4. Means mapping is happening somewhat like this. X is equals to 4 and y can be any number. Do you think it's a function, my dear friends? It's a function. See, this is different. This is many one function actually. Do you think it's a function? Sir, it's not a function, sir. To determine the types of functions, first it should be a function. Only one arrow should pass from the element. See here. Close this. Only one arrow must pass to the element, but multiple arrows are passing from the element. So do you think it's a function? First of all, it is not a function only. When it is not a function, how will you decide what type of function it is? Nonsense. Okay. Next example. X comma y such that y is equals to x square and x comma y belongs to real numbers. Y is equals to x square. Now, I'm having -2, -1, 0, 1, 2. This is x, this is y. 1, 2, 0, 1, 2, 3, 4. What is -2 whole square? 0. Sorry, -2 whole square is 4. What is -1 whole square? 1. What is 0 square? 0. What is 1 square? 1. What is 2 square? 4. What happened? It's running. First, is it a function, my dear friends? Is there any number in number system which does not have square? Take any number, you can square it. There's no number in number system which does not have square. So every element in domain has a mapping. Is there any element in number system that you square it and you will get two answers? You square it, you will get two answers. 2 square, answer is only 1. -2 square, answer is only 1. -5 square, answer is only 1. See here. From every element in domain, arrow should pass. Yes, sir. From every element in domain, arrow is passing. Is only one arrow passing from every element? Yes, only one arrow is passing from every element. So is it a function, my dear friends? Yes, it's a function. He's just asking what's a function or not. Answer is it's a function. Okay. Now, third one you think and tell me. X comma y such that x is less than y and x comma y belongs to real numbers. Think and tell. Don't tell me what type of function is this. Tell me whether it's a function or not. I'll wait for 1 minute. You are telling answer as no. Let's check. X, y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sir, 1 is less than 2, 1 is less than 3, 1 is less than 4, 1 is less than 5. Here only gone. Only one arrow should pass, but multiple arrows are passing. So it's a function. No, it's not a function. Next, point number 4. X comma y such that x plus y is equals to 5. It's a function or not. X comma y belongs to real numbers. Let's check it's a function or not. X, y. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. If x is 1, what will be y? 4. X is 2, y will be 3, 2, 1, 0. So can you see, my dear friends, only one element, only one arrow is passing. You can substitute any number from real numbers instead of x, right? So I'll say, yes, sir, it's a function. I'm sure that it's a function. Okay, can you tell me what type of function is this? Is it 1, 1 or onto or into or bijective? First, I'm sure that it's a 1, 1 function. Because you substitute one value for x, you will get only one value for y. Okay, so it's a 1, 1 function. Only 1, 1 mapping option is there. So I can say only 1, 1 function is there. You can even tell it's an onto function and it's a bijective function. Okay. So in 1, 1 function, onto function and bijective function. Next, example number 5. F of x is equals to 2 power x. Okay. Option A, 1, 1. Option B, 1 many. Option C, many 1. Option D, none. First, I can say that option B cannot be the answer because 1 to many is not a function only. Now, is it 1, 1 or many 1? Now, if you substitute x as any value, will you get only one answer or will you get multiple answers? 2 power 1, 2. 2 square, 4, 2 cube, 8, 2 power 1, 2, 2 square, 4, 2 cube, 8. Means multiple answers you are getting. So many one can't be the answer. Okay, many one function can't be the answer. So what is left? 1, 1. Okay, so every element of x has one solution. That's the reason it is 1, 1 function. Next. Can you tell me what is the range of 3, 0, 2, 0, 1, 0, and 0, 0? What do you think is the range for this? Range of 3, 0, 2, 0, 1, 0, and 0, 0. Don't tell like this. Sir, 0, 0, 0, 0. No, answer is 0. This is not the answer. This is the answer. First time it's not 1, it is 0. Range means where the mapping is ending. Okay, that would be your range. Next, last question. We'll go for the next concept after this. I'm asking what is domain and range of y is equal to x square. Option A, reals, comma, natural numbers. Option B, real, comma, real. Option C, real, comma, non-negative real. Option D, none. X is domain, y is range. So can I say it will be real and non-negative real? How's a real and non-negative real? X is domain. You substitute any number in number system, and if you square it, obviously answer will be non-negative only, no? Is there any negative number for a square of a number? No, you square any number, you will get non-negative number only. You will never get natural number or any other number. Like 0 square is that. What is 0 square? 0. 0 is not a natural number. It's a non-negative real. Okay. So any number you take and you square it, you're going to get non-negative number itself. Okay. So I hope all these concepts are clear. There's nothing much difficulty in these concepts. So let's proceed further. Yes, sir. Let's proceed further. Now, one question is there. It belongs to relations. Just tell me what type of relation it is. I'm having example like this. X plus y is equals to 2x. What do you think? What type of relation it is? Reflexive, symmetric, transitive, and equivalence. Let me tell you. Send that x there. So can I say it will be y is equals to x? What is the connecting word here? Equal to, right? What is equal to what type of relation it is? Equivalence relation. Okay. He gives question like this, x plus y is equals to 2x, and is asking you what type of relation it is. Don't get panicked. Okay. Here it is equivalence relation. So y is equals to x, it is simply an equivalence relation. So my dear friends, types of functions are also completed. Now 4 important points are there. Let me explain those 4 points. First, basically, what is a function? What is the main purpose of a function? Okay. Function, my dear friends, it's like a machine. Okay. In this machine, you give input and you'll get an output. Okay. These functions, they are represented by symbol f of x. It's a symbol for a function. Like say, for example, in my case, function is 2x. Now you give any input with respect to x. I'm telling x is equals to 1. What will be the output? 2. I'm telling x is equals to 3. What will be the output? 6. I'm telling x is equals to 4. What will be the output? 8. I'm having x is equals to plus symbol. What will be output? 2 plus symbol. I'm telling x is equals to heart. What will be the output? 2 heart. Okay. You introduce any input, you will get output. That's how a function works. Okay. Like say for example, he has given a question in your book like this. Example. He is telling f of x is equals to 1 divided by 1 minus x. I'm asking what is f of minus 1? Instead of x, you'll substitute minus 1. 1 divided by 1 minus of minus 1. 1 divided by 1 plus 1, which is equals to 1 by 2. So function, my dear friends, it's like a machine where you give an input, you will get an output for it. Or one more example. I'm telling g of x is equals to x minus 1 by x. I'm asking what is g of minus 1 by 2. So it will be minus 1 by 2 minus 1 divided by minus 1 by 2. What is minus 1 by 2 minus 1? Minus 1 minus 2 by 2 divided by minus 1 by 2. 2 to cancel. Minus 3 by minus 1. Minus minus cancel 3. Okay. So I hope it's clear what is the function. Function is nothing but a machine where you give an input, you are going to get an output. That's it. There's nothing much special. Is always represented by f of x. Now, what is this odd function, even function, and composite function? See here. Now, example. F of x is a function, right, my dear friends? Now, instead of x, if I substitute minus x and final resultant is x, then I call it as an even function. Okay. Now, instead of x, if I substitute minus x and I'll get minus f of x, then it is supposed to be an odd function. Sir, I will not get minus, I will not get plus. Then is it even or odd? Then you can't tell what type of function it is. Like say, for example, I am telling f of x is equals to 3x square. 3x square plus 5. Now, instead of x, I am substituting minus x. 3 into minus x whole square plus 5. 3x square plus 5, which is equals to f of x. So, can you see when f of minus x you substituted, you got f of x? Yes, sir. So, that's the reason I'll say, what type of function is this? It is simply an even function. Instead of x, you substitute minus x and final resultant is x. It is called as an even function. Now, what is odd function, my dear friends? I'm telling f of x is equals to 5x cubed. Now, instead of x, I'm substituting minus x. 5 into minus x whole cube. That is minus 5x cubed. That is minus f of x. So f of minus x has given you minus f of x. So what type of function is this? It's an odd function. So I hope it's clear what is odd function and what is even function. Yes, sir. Odd function is f of minus x is minus f of x. It's an odd function. Even function f of x, f of minus x is equals to f of x. It's an even function. Okay. We did not do so many questions on this, my dear friends. It's why? Because it's an outdated concept. Very rare. I guess last 8 years back, they have asked question on odd function and even function. What you need to remember is composite function and inverse function. This you need to remember. Odd function and even function, they're not that important for our exam perspective. Now, Let's understand the next two functions, composite function. Now, what is this composite function? Composite function means if you merge the functions together, composite function, you go ahead and merge the functions together, you call it as composite function. Okay. I'm having f of x is equals to 2x. I'm having g of x is equals to x square. Now I'll merge them together. He is asking what is f of g of x or fog x. Now see here, f of x is 2x, right? Now instead of x here, I'll substitute g of x. Instead of x here, I'll substitute g of x. 2 into x square. That is equals to 2x square. So f of g of x is 2x square. Next step. G of f of x. How will we calculate g of f of x? G of x is x square, right, my dear friends? Now, instead of x, I'll substitute f of x. G of f of x. 2x whole square, which is equals to 4x square. Okay. So, this is supposed to be our composite functions, where we are merging two functions together. F of g of x and g of f of x. Let me take more better example for your clarity, my dear friends. I am telling f of x is equals to 1 divided by 1 minus x. G of x is equals to x minus 1 by x. F of x is equals to 1 divided by 1 minus x. G of x is equals to x minus 1 by x. I need to calculate fog x. I need to calculate go of x. Now, f of g of x. Fog x means f of g of x. Means instead of x here, I'll substitute this g of x. So it will be 1 divided by 1 minus g of x. 1 divided by 1 minus x minus 1 by x. 1 divided by x minus x plus 1 divided by x. X cancel. 1 divided by 1 by x. X goes to the numerator. F of g of x. Now g of f of x. You are merging the two functions again together. G of f of x. What is g of x? X minus 1 by x, right? Now instead of x, I'll substitute f of x. F of x minus 1 by f of x. F of x is 1 divided by 1 minus x minus 1 divided by 1 divided by 1 minus x. Let's take an LCM. 1 minus 1 minus x divided by 1 minus x whole divided by 1 minus x. Cancel. Cancel. 1 minus 1 plus x. So cancel. Answer is x. Okay. Sir, will f of g of x and g of f of x be same? No, it's a coincidence. Like in this example where they're same, 2x square and 4x square, no, right? So sometimes it may happen, sometimes it will not. So don't worry about that. There's no rule that compulsory it should happen. Now try this example and tell me. F of x is equals to x plus 3. G of x is equals to x square. I want you to calculate f of g of x. G of f of x. You need not type it in the chat box because x square, all those things won't come. But just write. I'll wait for 1 minute. So I hope you got the answers, my dear friends. F of x is equals to x plus 3. G of x is equals to x square, right? First, f of g of x. Instead of x here, I'll substitute g of x. X square plus 3. Now g of f of x. Instead of x here, I'll substitute this one. X plus 3 whole square. X square plus 9 plus 6x. Okay. So I hope composite functions are also clear. We understood odd function. We understood even function. We understood composite function. Composite function means simply you are merging the functions together. That's called as composite function. Now see here, my dear friends, inverse functions. It's an important concept, but again, I'm seeing that from the past 2-3 years, I don't know why this person is not asking even a single question from relations and functions. Only on sets they are asking questions, not even a single question on relations and functions. So we may expect at least 1-2 questions in this examination on relations and functions. Let's see. Now, inverse function. Now, what is this inverse function? Say, for example, I am telling f of x is equals to y. Okay. Now I am sending y to left to right side. So it will be x is equals to f inverse y. Now instead of y, I'll substitute x. I'll get f inverse x. Sir, what nonsense is this? See here, I'll tell you. First, what you'll do is that equate the function to y. Equate the function to y. Next, make x as subject. Third, replace y with x. Sir, what is this concept of inverse function, first of all? My dear friends, function, basically, if you take a graph, and if you draw function in that graph, the graph comes somewhat like this. Okay, this is how the function graph looks. Now, I want the inverse graph of this. To calculate the inverse graph of this, we calculate inverse function. Like after this, the graph looks somewhat like this. This is the graph of f of x. This is the graph of f dash of x. Basically, in very high level of financial management sums, we'll be using this concept. As a reason, this is there in foundation. So that you understand it when you do very high level of financial management sums. You don't even have it in CA final. After CA final, if you want to pursue career in financial management, there you will see this type of inverse functions being used. Okay. Let me take one example. I am telling f of x is equals to 2x. I am asking find the inverse function. What is the first step? You will equate the given function to y. Second step, you will make x as subject. Third step, you will replace y with x. So inverse function of 2x is x by. Next example. F of x is equals to x minus 1 by x. First step, you will equate the function to y. Second step, you will make x as subject. Let's make x as subject. Cross multiplication. X minus 1 is equals to xy. Take xy here, 1 here. X minus xy is equals to 1. Take x common. 1 minus y is equals to 1. X is equals to 1 divided by 1 minus y. Third step, replace y with x. F inverse x is equals to 1 divided by 1 minus x. Okay. This is how you do. This is first example. This is second example. Next, example number 3. And we have only 2 questions in our book. But let's see if I can get anyone. X minus 1 by x. 1 divided by 1. It's very possible. Example number 3. F of x is equals to x plus 3. First step, you will equate to y. Second step, you will make x as subject. Third step, f inverse x will be instead of y, you substitute x minus 3. Okay. So I hope it's clear, my dear friends, what are inverse functions. One question we have on logs, but let's not do that because logs we haven't completed yet. So inverse function, simple. First, you will equate the given function to y. After that, you will make x as subject. Then instead of y, you will replace it with x. Okay. We need not do any research on this because very rarely they are asking these questions. Rather, I can say they are not asking only. Try this one more question. It's not required. 3 would be sufficient type. Try this example and tell me the answer. I am telling hx is equals to 10 power 1 plus x. Domain is 0 less than or equals to x less than or equals to 9. Then range is what? Option A, 10 less than or equals to h of x less than or equals to 10 power 10. Option B, 0 less than or equals to h of x less than or equals to 10 power 10. Option C, 0 less than h of x less than 10. Option D, none. That's a given question. Think, solve and tell me the answer. Domain is 0 less than or equals to x less than or equals to 9. I want you to calculate the range. How will you calculate the range? Instead of x here, you will substitute 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say simple. First, what we'll do, instead of x, let us substitute 0. Yes, Yogita, perfect answer is option A. Instead of x, let me substitute 0. Instead of x, let me substitute 1. Let me substitute 2, so on. Let me substitute 9. 10 power 1 plus 0, that is 10 power 1, 10. 10 power 1 plus 1, which is equals to 10 square. 10 power 1 plus 2, which is equals to 10 cube. 10 power 1 plus 9, which is equals to 10 power 10. So can you see value is starting from 10 and it is ending at 10 power 10? So I'll say, what is the answer? 10 less than or equals to h of x less than or equals to 10 power 10. Okay. Simple, sir, nothing much complicated. Now, I've shared few questions in your group, ICM material questions itself. Make sure that you will solve them today. Okay, in that one graph sum is there on functions. Only one sum is there on graph. Try that if you can do that. Okay. So that's all regarding sets, relations, and functions, my dear friends. There's nothing much special to solve more on that. Now let's go to probability. Some 20 to 25 minutes. Let's discuss the concepts on probability and let's wind up. Tomorrow we'll be having two sessions, one in the morning and one in the evening. Okay, morning 1.5 hours, evening 1.5 hours. Okay. Now, probability, it's an important chapter, my dear friends. We can expect around 7 marks weightage from this. Okay. As said, you central tendency and dispersion, introduction to statistics, probability, index numbers. If you're perfect with these 4 chapters, you will be in a position to score 32 marks. If you are perfect in the 4 chapters of mathematics, that is time value of money, sets, relations, and functions is take 2 marks. Next, permutations and combinations 5 marks, sequence and series 5 marks. You will be in a position to get 57 marks at total. Only these chapters without logical reasoning, nothing, differentiation, integration, nothing, you will be in a position to get 57. And let's take LR somewhere around 15 marks, we can be in a position to score. So even after probability, if you directly jump to LR also, you should be in a position to score 72 marks in the examination. Okay. Now, let's start with probability, my dear friends. Some 3 pages are there. We'll cover those 3 pages. So basically, what is a probability? To say frankly, my dear friends, probability is a percentage calculation of future events where you are not multiplying with 100. You are doing percentage calculation of future events without multiplying with 100. That is called as probability. That's it. I'm asking what is the probability of you clearing the CA foundation exam? You are telling probability 100%. There's a 100% probability that I'll clear CA foundation exam. Right? That's nothing but you are telling the percentage of chance of occurrence of future events. That's called as probability. What is the probability of you eating biryani tomorrow? 40%, sir. Or 0.4. You don't multiply with 100. You call it as probability. You multiply with 100, you call it as percentage. Percentage calculations for future events where you are not multiplying with 100 is called as probability. That's it. There is nothing much special here. Okay. This probability, my dear friends, you'll write it as favorable cases by total cases. You'll do favorable cases divided by total cases. We call it as probability. So what are favorable cases? Cases which are favoring your event. Favorable cases, cases which are favoring the event are called as favorable cases. Sir, what are total cases? Total amount of cases are called as total cases. This favorable cases plus total unfavorable cases, if you do, you get total cases or sample space. Let me take you through an example. I'm tossing 2 coins, my dear friends. If you're tossing 2 coins, what are the total outcomes? Total cases. You can get either head-head or head-tail or tail-head or tail-tail. Total 4 cases are possible. Right? I'm asking you, what is the probability of getting 1 head? What is the probability of getting 2 heads? What is the probability of getting 0 heads? Now, what are favorable cases for probability of getting 1 head? In how many cases you have 1 head? These are the 2 cases where you are having 1 head. What are probability of getting 2 heads? In how many cases you are having 2 heads? Only in 1 case you are having 2 heads. In how many cases you are having 0 heads? This is the case where there are 0 heads. Now, my dear friends, remember when I'm telling probability of one head, probability of two heads, probability of zero heads means it's a probability of exactly one head. It's a probability of exactly two heads. It's a probability of exactly zero heads. That exactly word will not be there here, but you have to assume that the word exactly is there over there. P of one head means probability of exactly one head. P of two heads means probability of exactly two heads. P of zero heads means probability of exactly zero heads. Total cases are 4. So what's the probability? 2 by 4, 1 by 4, 1 by 4. And you know what's the best thing? Add all these things, you'll get the answer as 1. You add all these things, you'll get the answer as 1. Next. I'm tossing 3 coins. What are the total cases if you toss 3 coins? Head, head, head. Head, head, tail. Head, tail, head. Tail, head, head. Tail, tail, tail. Tail, tail, head. Tail, head, tail. Head, tail, tail. Total 8 cases. I'm asking what is the probability of one head? Exactly one head. Exactly two heads. Exactly 3 heads. And exactly 0 heads. To see, my dear friends, in how many cases you have exactly one head? Favorable case, favorable case, favorable case, favorable case. Sir, I'm having 3 cases where I'm having exactly one head. Exactly 2 heads. I'm having 3 cases where I'm having exactly 2 heads. Exactly 3 heads. I'm having 1 case where there are exactly 3 heads. 0 heads. Exactly 1 case where there are 0 heads. So what's the probability, my dear friends? 3 by 8, 2 by 8, 1 by 8, 1 by 8. So this is 3. 3 by 8. 3 by 8, 3 by 8, 1 by 8, 1 by 8. So can I say resultant is 1? Yes, sir. Sir, why you are doing always heads? Why not tails? You can do probability of 1 tail, probability of 2 tails, probability of 3 tails, probability of 0 tails. Answer will be same. Okay. Now I am tossing single coin. Single coin. What are total cases? Head, tail. Total cases 2. I am asking what is probability of head. I am asking what is probability of tail. In how many cases you have head? Only 1 case, sir. In how many cases you have tail? Only 1 case, sir. So what's the probability? Favorable cases by total cases. Favorable cases by total cases. Again, total will be 1. Okay. So I hope the simple probability concept is clear, my dear friends. So what's the basic probability formula? Favorable cases by total cases. Earlier, my dear friends, this was a branch of mathematics. Now this became branch of statistics, especially in financial management and cost accounting. Exhaustively, you'll be using probability. You'll see in your CA Inter also in accounting, there and here you will be using probability and mathematical expectation. When you come there, you'll learn, don't worry. Now, probability, my dear friend, there are 2 broad divisions of probability. One is subjective probability, one is objective probability, classical probability, or priori probability. Subjective probability, my dear friends, it is applied in decision making. Okay, basically it is used in management. Like I am telling, India and Sri Lanka match is going on. I am asking Indians who will win. They are saying India will win. I am asking Sri Lankan people who will win. They are saying Sri Lanka will win. It's what's happening here. The probability is changing from person to person. It is subjective. For one person, this is the probability. For one person, this is the probability. Okay. It is subjected to their minds and their thinking capacity. That is called as subjective probability. Basically, my dear friends, this is used in decision making. We don't use it in management. Next, objective or classical or priori probability. Some probability which you regularly use, that till now what probability we have seen, that's objective or classical or priori probability. Here, my dear friends, outcomes are known in advance. When you toss a coin, do you know what are the outcomes? Yes, it can be either head or tail, that's it. But it won't fall in middle. When you're tossing 2 coins, even there you know what are the outcomes. When you're tossing 3 coins, even then you know what are the outcomes. Those are called as subjective probabilities. Those are called as objective probabilities. Objective or classical or priori probability is a probability what we'll do in our syllabus. Okay. Here, my dear friends, we know what is the outcome in advance. Okay, that's called as objective, classical, or priori probability. I hope the concept is clear. Next, what is this random experiment? All this. From now onwards, my dear friends, definitions will start. Let's look into the definitions. Random experiment. Any activity performed randomly is called as a random experiment. You are tossing a coin. Randomly, you are performing. It's a random experiment. And there is one more definition also for this. Any experiment which has a random outcomes is also called as a random experiment. Any experiment which has random outcomes is also called as random experiment. Any activity which you perform randomly is a random experiment. Any experiment which has random outcomes is also a random experiment, my dear friends. Like say, for example, I'm randomly tossing a coin. Do I know what is the outcome? No, it's a random experiment. I'm rolling a die. Do I know what is the outcome? Again, sir, where we'll know, sir? We are rolling a die. We don't know where we'll get, what answer we'll get. So again, it's a random experiment. You kept a pack of cards. You are picking up one card. Do you know which card you will get? No, sir, you don't know which card you will get. So again, it's a random experiment. Any experiment where the events or outcomes are random, that's called as random experiment. Okay. Example, tossing coin and all. Now see here, my dear friends. You are tossing 3 coins. Okay. This tossing 3 coins is a random experiment. Okay. For this random experiment, you can get either 0 head or 1 head or 2 heads or 3 heads. These are called as outcomes or events. Okay. This random experiment is also called as trial. The outcomes of a random experiment are called as events. Random experiment is also called as trial. You may ask in theory all these things. But in practical, we don't use all these things. This point will come back later again. Now see here, my dear friends. What are these favorable cases, unfavorable cases, and total cases? Favorable cases, unfavorable cases, total cases. Favorable cases means those cases which are favoring your event. They are called as favorable cases. Unfavorable cases means those cases which are against the event. They are unfavorable cases. Obviously, my dear friends, favorable cases plus unfavorable cases will be total cases. See here. You're tossing 3 coins. You're tossing 3 coins. Okay. Tell me what are the favorable cases, what are the unfavorable cases, what are the total cases. Fine. 2 heads. What are the favorable cases for 2 heads? In total cases are 8, right? In 3 cases, you will get 2 heads. 5 are unfavorable cases. Total cases are 8. What about 3 heads? 1 is favorable case. 7 is unfavorable case. Total cases are 8. Just now we have recorded here, right? 8 cases. In how many cases you'll get 2 heads? 3 cases. In how many cases you'll get 3 heads? 1 case. Okay. I hope that's fine. Now, favorable cases plus unfavorable cases will be equals to total cases, my dear friends. Right? I am applying probability on both sides. Probability of favorable cases plus probability of unfavorable cases will be equals to probability of total cases. Okay, what is the formula for probability? Favorable cases by total cases. I am asking what is the probability of total cases. Instead of favorable case, I'll keep total case. 1. So probability of favorable case plus probability of unfavorable case will be equals to 1. If you want, you can even write like this. Probability of favorable case is equals to 1 minus probability of unfavorable cases. Basically, this concept, we use it when a word at least is given in the question. I'll tell you when the next class, when we discuss the sums, I'll tell you more about this concept. Okay. I'll give a small example now. There are 3 coins where you are tossing. Okay, these are the 8 cases what you got, my dear friends. Okay. Now, I'm asking what is the probability of 3 heads? What you'll tell, what is the probability of 3 heads? 1 by 8. Instead, can I do like this? 1 minus not getting 3 heads? One minus, in how many cases you didn't get 3 heads? In 7 cases, I didn't get 3 heads. 1 minus 7 by 8. Even there, you will get the same answer, 1 by 8. Instead of eating directly like this, you are eating like this. Okay, simple. Next, probability of 2 heads. What is probability of 2 heads? 3 by 8. Instead of doing like this, can I say 1 minus not getting 2 heads? These are the cases where you are not getting 2 heads. Either you are getting 1 head or 3 heads. 1 minus 5 by 8, which is still again equals to 3 by 8. Okay. Range of probability, my dear friends, it will be 0 to 1. I hope you understand this point number 12. Range of probability will be 0 to 1. Sum of probabilities will be 1. Remember this because I wrote it somewhere. I don't know where I wrote, but let me write it here. Sum of probability will always be equals to 1. Range of probability will be 0 to 1. 0 being impossible event, 1 being certain or sure event. Your probability must lie only in between the 0 and 1. So once let me revise everything what I have taught. First, probability. Probability is nothing but you are calculating percentage for future events. Next, what is the sum of probability? Probability is also called as chance or odd. No, probability formula will be favorable cases by total cases, right? What are favorable cases? Cases which are favoring the event. What are unfavorable cases? Cases which are not favoring the event. Total cases will be favorable cases plus unfavorable cases. Total cases is also called as sample space. What's the probability of total case or sample space? It is equals to 1. Next, sum of probability is always equals to 1. The range of probability is 0 to 1. 0 being impossible, 1 being certain or sure event. 1 minute. Yeah. So basically earlier it was a branch of mathematics. Now it became branch of statistics. Next, I said you 2 broad divisions, subjective probability and objective probability. Subjective probability, we use it in decision making. We don't use it in our syllabus. It changes from person to person. Objective probability means it remains same everywhere. Next year, outcomes are known in advance. But all the sums what we do are based on objective probability itself. Then we understood random experiment, and then we understood outcomes of random experiment. Any activity what you perform randomly or an activity where outcomes occur randomly is called as random experiment. The outcomes of this random experiment is called as events. Okay. Now, so that's it, my dear friends. Today, we are winding up early. Balance things. We'll see in tomorrow's class. Tomorrow, I'll let you know the facts.